This is an easy process to go through and solve because you guys have already worked with these units before. You've worked with dollars. You've worked with pennies and dimes. So you've internalized most of these calculations. When you were asked to do these stupid word problems in, say, a math class, okay, why were they making you do them? Did they really expect you were going to ever encounter a Douglas in your life that is like, I only want silver things? Why are they creating these kind of arbitrary and false systems for us to manipulate? The story makes it a little bit more real, a little bit easier for you to manipulate and kind of hang that information on. Even then, though, you've internalized that calculation. Okay? I would bet a decent handful of you feel that you could solve this question right now without writing anything down, right? Yeah? Okay. And if I asked you to write it down, you'd be like, that's stupid, that's so much work, why are you doing that? All right, so let's go through and write that down. What is our process? What do we need to do? What do I want? I want dollar bills. What am I starting with? Pennies. I'm going to call that pennies. Okay, how many pennies am I starting with? 100. And I now want to convert that into dollar bills. So in my conversion process, I would go through and say, I want to convert pennies into dollar bills. Right? I put pennies in the denominator so that it would cancel and I could get dollar bills in the numerator, right? Everybody see that? Makes sense. Yeah. Does that conversion exist in the world of this question? No. It does not exist because for that to happen, I have to get the dollars from Douglas, and Douglas is just weird and won't accept pennies because pennies aren't silver. Okay? So that conversion doesn't exist. Okay? So what conversion does exist that I could potentially use? Okay? I can convert pennies into dimes. Right? What is that conversion? We're here 10, 1. Okay? And even 1 to 10. You mean 1 to 10? Okay. So the placement of that number becomes very, very important. I go, well, 10 to 1. 10 should always be, the number in the numerator. There's a sociocultural norm for that. Does that mean you are following the sociocultural norm? Sometimes you are, sometimes you aren't. Okay? So let's remove the ambiguity. Thank you for whoever voiced that out for me. And instead of saying 10 to 1, say 10 cents, 10 pennies is 1 dime. Now the location of the number is defined because I've already spaced out where the units go. Okay? Would I have an answer now, though? No. All I've done at this point is converted the pennies into dimes. Okay? So that would be, who do we get? Harry talking to Sally. Right? Then what does Harry need to do? Then talk to Douglas. And if we think about how we've seen these problems before, they're typically broken up into individual conversions. Okay? Which isn't necessarily wrong, but each of those conversions means you have to write an answer. Every time you write that answer, you also then have to rewrite that answer so you can start the next question. You're repeating writing. Okay? Which could be a good thing if you were a computer and you didn't make mistakes. But you make mistakes. So is there a way that instead of having to show that answer each time for those individual conversions, that we just run it all together? Okay? And this is where using the units can help us out. What unit would I have after running this calculation? Okay. What happened to the cent unit?
Cancel
it canceled out. I'd be left with dimes. This information is embedded in the work, and if I look at and interpret the work, it's already there. You okay?
You shouldn't pick things up.
Oh, you just dumped the whole thing of coffee in there, didn't you? Awesome. Okay, we're at dimes. We actually have a new question now, because I don't want pennies anymore into dollars. I want dimes into dollars. So now what can I go through and do? I want dimes in the denominator. Why do I want to place it in the denominator? So that the unit cancels. What number should I put there? And this is a challenging question. Okay, so let's take a second on that and walk through it a little bit. Okay. The unit that I want there, or the number that I want there, I don't know. Okay. And I'm hearing a lot of people say 10 because you're given 10 dimes. You're saying 10 because what you have internalized, and this is the problem again, your internalization versus the external writing it out.
We talked about that with dating.
What?
It's not your internal thing. You need to get past your internal thing. Just saying.
Refocus. What do we want for an answer? Dollars. Is there a relationship between the dimes and the dollars? Yes. Now that I know what I'm trying to relate, now I can bring in a numerical value. Okay? I've explicitly stated what I'm trying to relate. Now the numerical value makes sense. And that numerical value says 10 dimes is $1. What happens with our units? Well, the dimes would now cancel, and what would we be left with? Dollars. We now have the entire process. Now we can enter it into the calculator and we can get our answer. Okay? I would hazard a guess that even if I made you break this down into the individual calculations, that you probably would have written 100, maybe at best, times 1 over 10 times 1 over 10. Is that the same as the work we've shown? What's wrong with it? It's missing all of the units. And your argument, well, you get the same number. You do. You do. So let me show some more work to get the same number. Because what number do we get here? 1, right? I'm going to take 100 and I'm going to subtract 99 and I get 1. Does that work make any sense with the question? No. So does the process of how we get to the number matter? Yeah. Okay. It's hugely important when we go through and solve. Okay. In this kind of a question, you've already experienced all of this, which means you could internalize the crap out of it because you've done it for at least, because we didn't get any of the age things, at least 18 years. Okay? Awesome. I don't care. Okay? That's not the point of walking through the process for the conversion. The point of walking through the process on the conversions is that what happens when we switch it to a unit system that you have no clue about. Do you have any idea what Snorlaxi or Skittle farts are?
I do.
Right? That's lucky because I don't know what they are. Okay? These are entirely made up. Okay? And this goes back to this, why would we ever have these stupid word problems? Okay? So that we can figure out the process. Because eventually what's going to happen is you will move into a system, a field that uses words that you're like, what the hell is that? They just made that up. A mole is not a cute, fuzzy little... I wouldn't argue they're not very cute either. But they're not this fuzzy little animal. Okay? It's a number of things. That's allowing me to do a conversion. Why do I want to do that conversion? Wait for unit 3. Okay? But we're using a unit system that you can't really comprehend. That doesn't mean we can wait for you to figure it out. We have to continue to use that unit and that manipulation in a bunch of conversions. Because what's going to happen the more you use that unit? It gets easier. And you start to actually understand the meaning of the unit because you're working with it. Okay? It's building on that knowledge. If we wait for you to just have divine intervention all of a sudden go, oh, I totally understand what a mole is, we'd never be able to get through any of the conversions to be able to relate anything in chemistry. Okay? And if we push that all the way out, we wouldn't be where we are within the field of science. Okay? We create systems and models that allow us to move forward, even if we have a hard time understanding it, but those models allow us to build. Okay? So what we're doing within this conversion process is not, can you convert millimeters to kilometers? Okay? It's not Skittle parts in Snorlaxy. It's not kilometers into miles or kilometers per hour into minutes. Okay? I really don't care about that. What I care about is the unit process that you're moving through to do those conversions. If you choose to break it up into individual conversions, that is on you. That is your choice. I still need to see the unit work. Okay? What I am telling you is from my experience, the vast majority of people that break it into individual steps screw up the conversion. Okay? And the people that accept that they need to write out that whole process get it right. Okay? It takes practice because we're trying to force you to do something that you're like, I don't want to do because I've already figured it out. You haven't figured it out. You figured it out one potential way to solve one problem. The process that we're giving you for this is to solve all problems instead of having to memorize a distinct individual event for every single situation. Kind of make sense? So this conversion process, I know, is a bit of a pain. Okay? But you're saying, well, I'm just not going to worry about it until it shows up. It's going to show up in the third unit. You're not going to know the units. You're not going to know the process. You're not going to pass. Okay? Or you're going to have to spend the time memorizing a whole bunch of different formulas. Okay? And that becomes challenging. If you've got a process, there's no memorization of formulas. You just follow the process. Kind of make sense? Okay. What the hell? So we're Jiminy. Yeah, we're just going to have to skip that slide. Too many things overlapped when we changed the size of the slides. So let's take a look at this one. Right? Let's take a look. An automobile engine displaces a volume of 498 centimeters cubed in each cylinder. Displacement of the cylinder in cubic inches. What are we solving for? Okay. I want inches cubed. What am I starting with? Okay. So we're going to break that down because we had two giant references for people behind that, both with equal confidence. Okay. I heard 400. I'm going to stop. And then I heard centimeters cubed. Okay. What we were given was centimeters cubed. Okay. We're focusing on the unit in this whole process. Once I know what I was given, then I can interpret or add in the value. The value in this case was 498. Are centimeters cubed the same thing as inches cubed? No. So what has to happen? I need to do a conversion. I need to get centimeters cubed into inches cubed. Does that conversion exist? Yes. Okay. What is that conversion?
0.061.
Nope. Because what you did there was a calculation. Okay. You've combined a conversion factor. What is the conversion? Centimeters to inches is something that you are given. Okay. That's on the first page of the exam. And on the first page of the exam, it says what?
1 inch equals 2.54 centimeters.
Inch to centimeters. So the inch cubed, centimeter cubed was not given. What was given is inches to centimeters. So we would need to ensure that we actually canceled that there was a cube there, right? Okay. That cube, if we wrote it out, was centimeters, 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 right? Okay. So we could go through and say, well, that got rid of one of them, so what do I need to do?
2 more times.
I need to do it 2 more times. Everybody see that? That's a repeated calculation, right? Is there a shorthand for a repeated calculation? Right? Okay. That work is perfectly acceptable. Both of these work. Okay, if you gave me either the colored version or the black version down below, both of those are acceptable forms of work. If you give me this black version, guess what your answer usually comes out to be? I know, you're like, well, what is it? It's going to be about 250. I'm really ballparking that. Inches cubed. Okay. Most people with the black calculation will give me 250 inches cubed. Okay? Because William, you were convinced you had the proper inches cubed one. Can you tell me what the actual number was for the colored version? Yeah, do the full long one or the condensed one if you wanted, because you had that handy. Did I cheat and provide it for myself? I may have given it to myself. Yeah, we carry some numbers around. I believe we get 30.3288. 3288, really? I got 3898.
Wait, hold on, I got wrong.
That's okay.
3898.
Okay. The work in both these cases is identical. Yet somehow we're getting different numbers. Why? Okay? Calculators don't make mistakes, but humans entering those things into calculators make mistakes all of the time. Okay? So when people are like, you'll never have a calculator, you have to know the process. You have to know the process so when the calculator spits out an answer, you're like, that makes sense. Okay? Not, 250. Right? It's not 250. If someone actually has it, you can give me the better number. It should be less than that. Maybe 190. 498. Just give me 498 divided by 2.54. Did you just tell me? 196? 498 divided by 2.54. 196. Thank you. Don't give me scientific notation crap right now. 196 point what? 06. Okay. Still, numerically, very, very different. What happened? When we put that cube there, you cubed the units. Did you cube the numbers? No. You have to cube the numbers in your calculation. When you write it out, it makes it kind of obvious that you have to input the number a whole bunch of times, right? You can enter it into the calculator with the cube as long as you ensure to distribute that cube. That is why this is a trap. This exact question is asked multiple times, okay, across courses. I get faculty insisting that this is a dumb question, we need to remove it because students don't make this mistake. The success rate on this question is less than 60%. Okay? The process is critical to solving this. The process with understanding the mathematics is critical to solve this. Okay? This is a really simple calculation to go through and solve, but if you start taking shortcuts, the whole process crumbles. So when I insist on you writing everything out, it's because I can see it in this question. This is an exceptionally straightforward question that does not ask a lot of you. The success rate on this should be greater than 90%. Okay?
On my calculator with the picture, like the color version, I didn't get 30, so I was just wondering.
What did you get?
65 or something.
Sounds to me like you missed a 2.54.
You divided it by 3 and you didn't cube root it or whatever you want to call it.
Yeah, to get the 60, because you're off by roughly 2 there, it sounds to me like you missed one of those.
Okay.
I'd have to look specifically at your calculator. Okay? So for those of you wondering, when you test a question in your textbook and you're not getting the answer right, that's a giant red flag that you need to talk with someone about the process to ensure you're getting it right. Not just be like, oh, that means I have to do it one more time. That doesn't work that way. Because on the exam, you're not going to be like, oh, that was the answer. I just needed to do one more step. No, you got it wrong, and you're done. Make sense? Okay. Let's make it a little bit more difficult, and by a little bit more difficult, a lot more difficult. Let's see what I can do. Okay. There's a lot of information on here. So this was our step process.
So for the last question, the answer would have been the 31?
The 30. Okay. So if I ask the question, how many seconds of molecules of caffeine are in 0.0350 grams of caffeine? How many of you know what a second is? As in Carl, yeah. Actually, yeah. A Sagan was named after Carl. It's the number of universes. Okay, or not universe, the number of galaxies in our universe. Okay, so that's a Sagan. Okay, so now I want to know the seconds of molecules of caffeine. So this is going to be a challenging question. What are we being asked to solve for? Seconds, just seconds? Seconds of elephants. Seconds of molecules. Seconds of molecules of water? Of caffeine. Our unit is not just the simple kilometers or miles. Our unit is seconds. Anybody want to write seconds out? No. Okay, what kind of abbreviation you want to use? Okay. Why did you say SA and not just S?
Because it, I don't know, it goes in more detail, but S is seconds.
S is seconds. S was already used somewhere else, so it makes sense to invent a new system. SA. Okay? So seconds is SA. Do we really want to have to write out molecules? Okay? So this one becomes challenging because MOL is mole, which is not molecule, so we can't use that. Whoops. Okay? And MOLE is just an alternate spelling of mole. Okay? My preference, MLC. Okay? And then caffeine. Well, I'm going to write its formula. C8H, nope. Calf. What am I given to start with? Okay. This becomes kind of a challenging question on what are we given to start with. How many of you knew what a Sagan was? Okay, nobody. So what did we have to give you? What a Sagan was. So for those of you saying, well, what we started with was 0.350 grams of caffeine, you were also given 1 Sagan of molecules of caffeine is 4 times 10 to the 9th molecules of caffeine, right? Okay. Do you know the relationship between grams and moles of molecules? No. So you had to be given that one too. Did you know the relationship between moles of molecules and actual molecules? Nope, you had to be given that one too. You were given 4 pieces of information. Which of those 4 should you start with? Okay. That is a personal preference. Okay. Sometimes it's a rhetorical choice. Usually, what people will go through and start with, to the far left, because that's what we said to go through and do, would be grams of caffeine. Okay? Why would we start with that? It's what we know. As we just addressed, we also know that 1 second of molecules is 4 times 10 to the 9th molecules of caffeine. We know 4 pieces of information. So telling me that I know 0.0350 grams of caffeine is a known, so are 3 other things. Why are you starting with grams of caffeine? It's not what we're trying to find. What we're trying to find is seconds of molecules of things. Seems like a good place to start. In my experience, when solving conversions, I usually start with a unit that is all by itself. It's not relating multiple things. Okay? There's a problem with that. What if your experience with solving conversions is limited? You are starting with that because someone told you to. Does anybody tell you what to start with on the exam? No. That is an inherently flawed argument for how to start a conversion. And yet, 99% of the time, if you ask someone to solve this, that's what they're going to start with. Why? Because of their experience in solving. Where did they get that experience? From somebody else that had that experience solving. Where did they get it? From somebody else. Okay? Somebody built an algorithm that said that's how you should do it. Right? That is problematic because you're now falling back on somebody else's knowledge to solve this. What do we want for an answer? Seconds, molecules, caffeine. Does grams of caffeine give me seconds, molecules, caffeine? No. So I would argue that's a crap place to start. Okay? How about molecules of caffeine? How about that last expression? Molecules of caffeine. Does that give me seconds of molecules of caffeine? Doesn't tell me seconds, right? Tells me moles. Is that seconds? No. So I would argue that expression is a crap place to start. I'm not sure I'm happy about you copying me, but that's okay. How about the next one? Grams of caffeine is moles of molecules of caffeine. Second of molecules of caffeine. Seconds, molecules of caffeine. That second expression gives me the exact unit I want for my answer. So which thing should I start with? Let's start with the one that actually gives me the unit that I want for an answer. That's a pretty good starting place. Okay? Now let's address the question of where do we want to place it aesthetically on the page. Okay? On the middle, what's the problem with putting it in the middle? You could write to the right, you could write to the left. You can go any direction. You're creating a system that has no boundaries. We don't live in a world with no boundaries. We've got lots of boundaries for a good reason. If we don't have boundaries, we tend to freak out a little bit. Okay? So we could put it to the extreme left of the page. Why would we pick the extreme left? You could just go to the right from there. Well, couldn't I pick to the right side of my page and then just go to the left from there?
We read from left to right. So we're getting right.
We aesthetically read from left to right, so where do we typically place things?
Left to right.
Left to right. How many conversions do I have to do?
4.
I don't know. Which means how much space do I need in between there? I don't know. That becomes a problem. Because I could have to write 20 conversions in there. If I've got 20 conversions, have I given myself enough space to solve it? So I would argue, as much as we want to solve left to right, we should not do it. We should actually solve right to left. Okay? So right next to that equal sign, I'm going to place in the numerator the thing that I want. Why do I want to place it in the numerator? Where's what do I want? It's in the numerator, right? Which means when I go through on the left-hand side, where should it show up? In the numerator. Sagan's, molecules, caffeine. Okay? I'm getting this from what? From this expression, right? Is it just the Sagan's and molecules of caffeine? No, it's the Sagan's and molecules of caffeine related to molecules of caffeine. So where does molecules of caffeine show up in this now? It needs to show up in the denominator. Do I have a numerical relationship between those two units? Yes. What is that numerical relationship?
1 Sagan molecule of caffeine to 4.00 times 10 to the 9th molecule.
Okay. I'm now placing, I was waiting for you to do the power 10, so good job. Okay. I'm placing the number because of where I've placed the unit. Okay. If that was the single calculation I had to do, you have no context of what this unit means, which means where are you going to place the number? Either on top or on bottom. It's literally a 50-50 coin toss. The odds of you getting that single calculation right are 50%. The testing bears that out. As soon as we switch to a unit system where you don't know it, 50% of you get it wrong. Okay? Because you aren't following a legitimate process behind it. Okay, so let's take a look at this. I brought in the answer I wanted, right? The unit. Yeah? Awesome. Am I done?
No.
Why not?
Because you can't cancel out the molecule.
At the same time I brought in the unit I wanted, what else did I bring in? A unit that I did not want, which means what has to happen? I have to cancel it out. I need molecules of caffeine, and I need them to show up in the numerator. Why? So that those units can cancel out. Okay? Am I given just the molecules of caffeine? Okay? If we've done this right and we need to use them all, we should only use them once. So I'm going to cross this one off because I've already used it. Am I given just the molecules of caffeine? Here's molecules of caffeine. That's awesome. Is it just molecules of caffeine? No, it's molecules of caffeine related to moles of molecules. Mother, yeah? Moles of molecules of caffeine. What is the numerical relationship for those?
1 mole.
Okay, somebody else saved 1 mole. Notice, you all went 1 mole, and I had that whole argument of it's 10 to 1. The 10 always goes on top. You just started with 1, and where do we place the 1? On the bottom. Okay? So don't be telling me the first number is always on top. It's not. Okay? The easiest number for you is usually what you place first. Okay? So 1 mole of molecules of caffeine is
6.023 times 10 to the 23rd.
molecules of caffeine. Okay? Okay, what happens? Molecules of caffeine cancel, right? Sweet. I got rid of that pesky unit that I did not want, so now I have my answer. I don't want moles of molecules of caffeine, so what do I have to do?
Take that second equation and put 1 mole.
No. You said 1. 1's already wrong. I want moles of molecules on top. Why? I want it to cancel out. So the placement of what I'm doing is all based off of the units that I've already started in my process. Okay? What do I have just moles of molecules of caffeine? No. So what do I got to do? I have to relate it to the grams of caffeine. That looks like an E. Let me fix that. What is the numerical relationship for those?
1
1 mole
Yes.
goes on top.
No, 194 grams.
194 goes on the bottom.
Man, you connected all.
If we go through and check our units, the moles of molecules of caffeine canceled, right? Cool. So now I'd be done because I would have seconds of molecules of caffeine. Dang it, I didn't deal with the grams of caffeine. What do I know has to happen? I would have to include the grams of caffeine in the numerator. Am I given just the grams of caffeine? Oh, I was. I don't have to do a conversion. Poof, there it is. It's literally the number. I just write the number in. What happens with the units? All the units that I don't want cancel out, and I'd be left with seconds of molecules of caffeine. Now what do I do? Now I can do a bunch of math with the calculator.
What's the safest way to do that?
Okay? Safest way to do that. Take everything in the numerator, multiply it out. Okay? So for those of you working on that for me with calculators, I need a number. So we'll take the whole numerator, and I want an equals. So that should be 0.035 times 6.022 times 10 to the 23rd. Officially times 1 times 1, right? What do we get? 1? Actually, I think it's 22. 1.8. What did we get? I'm guessing.
How about 2.1077?
2.1077 times
E22.
E22. What is E22? That's E. Times 10 is the E. Okay? So for those of you, because you gave me a weird face with that, you looked at it like 1.8. I got 2. I just did that long multiplication stuff in my head and got 1.8 versus 2.1 times 10 to the 22. Give me a little bit of credit. That's pretty damn close. Okay?
You did right.
That is a fair point, but I didn't actually calculate this one. Okay, yes.
After it counts like everything out in the original equation, would it be okay if we wrote it down underneath the numbers that I left?
Yes. Yep. At this point, this is your work. What I would expect you to do is enter it into the calculator. However you get it to the calculator, that's on you. Okay? So the bottom, 194 times 4 times 10 to the 9th. 7. Wow. That one wasn't quite as good. 7.76 times 10 to the 11th. Okay? Now what do you do? Now you'll enter this top one, and you'll divide by the bottom one. Okay? And you can enter that into your calculator. I'll tell you what I would do is a little bit different. I would take 2.1077, 7.76 times 10 to the 22nd times 10 to the negative 11th. First, what I did was shift that power of 10 up into the numerator by saying run the calculation in the other location by doing the negative. As soon as they're next to each other like that, I can simplify that further by saying, okay. Now what I enter into the calculator is the 2.1077 divided by 7.6 times 10 to the 11th. Okay. That is mathematical shorthand on my end that I would do from experience with the mathematics. You don't all have that experience. Minimally, what you should be able to do is what's in black. You need more chemistry, you should start shifting to what's in red. You should be starting to take some mathematical steps or shortcuts. Okay? but what's in black you should be able to get correct. Okay? Some of that is going to become challenging because you need to put that entire bottom thing in parentheses. Okay? There are other mathematical shortcuts on the calculator that you could use. That differs for every calculator, which means you want help with that. If you want help with that, tough. You'll figure it out when you get it wrong. No. If you need help with entering stuff into the calculator and coming up with shortcuts where you don't have to use as many parentheses, come talk to me. Okay? And I will work with you and your calculator to ensure you get the right answer. For this one, you should be getting something on the order of 10 to the 11th as a power. Okay? If you're getting something on the order of 10 to the 33rd, you're having problems entering it into the calculator. Yes?
So I divided that and you get 0.2716, but it's also times 10 to the 11. So we move the decimal.
What'd you say?
0.2716.
Times 10 to the 11th.
So that's not true, right?
Okay. So that's not scientific notation. Okay, if we shift that 2.716 times 10 to the... Okay, and now you have scientific notation. What's in red is probably what you would see on the exam.
And then if there's a show your work.
If there's a show your work, this would be a show your work right out of the gate. Not gonna lie, this is not a multiple choice question. This is a show your work question.
Can I show you the answer that I got and ask you if you
Aye.
need to write it this way? There's just a bunch of numbers after it.
Yeah, so let's address that real quickly with a show your work. So the answer we got, I'm going to have to write it in a little bit more space.
If it was a
2.716108 times 10 to the 10th. If this is a show your work, is that a correct answer in red? Whoops, we don't want all that. No, why not? Say that again. Sig figs. What's in red is wrong because you have not addressed sig figs. How many sig figs should you have in your answer?
3.
You should have 3 because?
Because of the 498.
Not because of the 498. Where did that go?
That's the least amount of significant figures you can, whatever,
And I don't know where you got 498. I'm confused by that.
490, oh wait, never mind.
Oh, yeah.
0.03.
The reason for why it's 3 is because of the grams of caffeine. That one's going to dictate our sig figs. 1 sig in a molecule is 4.0 whatever definition, which means that conversion has infinite sig figs. This one is definition, infinite sig figs. This one gets a little bit borderline, okay, but worst case it has 3. Our very first number has 3. So our answer should be reported to 3 sig figs. If we look at it, 271, the 6 is large. Add 1, and we get 2.72 times 10 to the 10th seconds of molecules of caffeine. Okay?
So if it's a show your work, you want us to do it.
Show your work, you got to address all aspects of the calculation, which includes sig figs.
Calculations when it's like the 28th power on that calculator.
You're entering it into the calculator wrong. Talk to me after class.
Go back to another question about the property of exponents, because before, last Thursday, when you were telling us about the sig fig, or about the conversions,
Mm-hmm.
and how they'd be, like, if you were converting from milliliters to
Mm-hmm.
inches, and you'd go, or like, let's do like centimeters to kilometers, and how you would have,
So first I'm going to stop you.
yeah.
No, I would never expect centimeters to
Well,
kilometers.
that was one of the examples that we had. So it was.
That's not how we solved it. We went centimeters to meters.
Centimeters to meters.
Then we
meters
went
to
meters to
kilometers.
kilometers.
Yeah, but with the power of x, with the property of exponents, how you had it was 1 centimeter is equal to 10 to the negative second meters. Would you be able to instead write that as 1 over 10 to the second instead of 10 to the negative second?
Yeah, so 10 to the negative second is the same thing as 1 over 10 to the second. Yes, you could write it like that. I would argue you probably don't want to do that because you're now taking it out of a power of 10, a negative power of 10 that your calculator understands, and turning it into a fraction, which your calculator already understood. The fraction you don't, and it's a power of 10. Okay? So I would argue that's a bad move because you're taking it out of a format that your calculator can deal with. Where you would use that is converting this across to 100 centimeters is 1 meter, which is perfectly fine and acceptable. And this is where I'm just going to kind of cut you off, unfortunately, because of time.
Yeah.
That's perfectly acceptable to memorize. The issue is that you're now changing the location of the power of the 10, which becomes problematic with how you memorize things. As long as your memory is solid, it doesn't matter. My experience, your memory is not solid.
Oh, just real quick, in the case that we do take a little bit longer, I'm a slow test taker. What do you take off for late tests?
10%. Don't be late. Okay? So this kind of comes to test-taking strategies, so we can just kind of talk through that. Okay? Yes, I fully understand you may be a slow test taker. If it's a legitimate disability, that's fine. You have to get it certified. If it's not a certified disability, I can't do anything about it. Okay? But your experience is being weighted against everybody else's experience in the exact same conditions. Okay? Because they're the exact same conditions, theoretically what we're testing on is your knowledge of the material and your preparation behind it. If you have some kind of disability or test anxiety, that now imbalances it, and you need to get that fixed by talking to disability resources. I cannot give that to you because that becomes a legal issue for me. Because now it's, well, I'm favoring you over somebody else. And that applies to everybody. Okay? Chemistry is one of those subjects that brings it out. And what a lot of it comes down to is practice. You just don't have the time to provide all of that practice. Because you don't have the time to practice it, guess what happens to your ability to take the test? It slows. Okay? Which means what should you do when you take the test? I kind of liked what you said, but I didn't get it all. What'd you say?
Prioritize.
You should prioritize, which is much better than what I thought I heard you said. Okay? You should prioritize. Okay? The less nice way of looking at that is looking through it, and if you see a conversion and you know you're bad at conversions, ignore the question. Don't work on it. You're already getting it wrong. Don't spend time on it. You're just going to waste time and get it wrong. Okay? So you need to prioritize by reading through the exam. You mean like step 1 of the directions, which was skim through the entire exam? Oh, man, it's like somebody intended to help me out. Okay? You need to go through that exam and find the questions that you know so that you can guarantee those points. You then need to go back through and be like, I may know this question, but it's going to take me half an hour. Point loss. Accept it, walk away. Continue on to the questions where you're like, I know how to do this, it's going to take me a little bit longer, but I can do it. Does that make sense? You have to triage your process. And for those people like, the real world's not like that, go to a hospital. Okay? Everything you will do in life is triaged. Everything. Exams should not be any different. Okay? Which, yes, makes it absolutely more stressful if you focus on the questions that you don't know. Don't. Focus on the questions you do know. Okay? So, compound units. Units for speed on a car, bike, walk to class. What would you say? Car would be miles per hour. 50? 50 doesn't work. Miles per hour. Okay? That could be 80 miles per hour. That could be 50 miles per hour. Okay? Depending on where you're at, that's going to change. Okay? It could also be, man, that's really irritating me. Okay? It could also be kilometers per hour. Why? Because we want to push your ability to do a conversion. So if a motorcycle is traveling at 105 kilometers per hour, what is the speed in meters per second? Why would I ever do that? To prove that you know how to do a conversion. That's the only reason we would do that. Okay? How would you go about doing that? Okay? So we already heard this 105 times 10 to the third. Wrong. Let's just assume that calculation was done right as far as powers of 10 go, because I can't do that in my head. You've now calculated per hour, not per second. You haven't completed it. Okay? This is why we need to write out the conversion. What do we want for an answer?
Meters per second.
Meters per second. What am I given to start with? Kilometers per hour. Why am I placing the kilometers and hours accordingly? Kilometers, you notice, is going in the numerator. Hours is going in the denominator. Why did I do that?
Because your end results are formatted that way.
Well, that's meters and kilometers. That's hours and seconds. Those aren't the same.
Unit, distance, time.
What are those units measuring? Meters is a measure of distance. I want distance in the numerator. Okay? The distance is in the numerator. We're aligning those units. They may not be the exact same unit, but I know the distance measurement has to show up in that place. Okay? Where does the 105 go? Okay? This is always kind of challenging. The 105 is closest to which unit? Kilometers or hours? Kilometers, which means the 105 goes with kilometers. What goes in front of hours? 1. Because if it was any other number than 1, it could be kilometers per half hour. That's an interesting way to interpret it, but that would work. Okay? It would not be 105 kilometers. Okay? We could do, if we did that at 2, it would not be 105. It would be 105 divided by 2. The given information clearly states it. Don't start internal manipulations. Okay? When we look at this, this becomes challenging. Is kilometers what we want? Is hours what we want? No. We have 2 things that we have to convert. All of our conversion processes are multiplication division. And what's special about multiplication division? Fancy C word. Communicative. It does not matter the order in which we do it. So which one do you want to address? Kilometers or hours?
Complex number first.
Okay. I actually already forgot what you said, but you shouted it really nicely. Which one did you want to do?
Because I already know that it's 60 seconds.
Okay, so you wanted to convert hours. Awesome. What do we want to convert hours to? Seconds.
Minutes, and then
Okay. Does that existent convert? Okay. How many people know that conversion? 3, 2, 1. Give me a number. There's the problem. No, it doesn't exist. One person gets it. What does the rest of the class do? So we can't go from hours to seconds. What can we convert hours to? Minutes. If you rewind back when we first started talking about this, we said how to do the calculation, 105 times 10 to the third, and then we said, oh, just divide by 60. We just divide by 60 once. Are we going to get per second? Nope. This is why we write down the units. So what is the conversion between hours and minutes? 1 hour is 60 minutes. The numbers get placed in the numerator and denominator based off of the units. How do we know where we place the units? Based off of where we started our solve. Why did we start our solve with kilometers in the numerator?
That's what we want in the end.
The measurement is distance that starts in the numerator and ends in the numerator. Kind of makes sense? Okay. The process builds on itself and allows you to solve without you having to think about it. Okay? Which is really weird because this is a critical thinking application, and the whole point of this is to think as little as possible. That's pretty phenomenally cool when we think about critical thinking. We're trying to not think. Neat. Okay? What happens to our units? Hours cancel. I don't want hours. That was good, so I canceled them. But I don't have seconds. So what do I got to do?
1 minute and 60 seconds.
Where do I place the minutes?
Up top.
Why do I want it up top?
You want to cancel some across.
So it cancels with the minutes in the denominator. What do I want on the bottom?
Seconds.
Seconds. This is why we write things down. It's okay. What's the relationship between minutes and seconds?
1 minute and 60 seconds.
1 minute, 60 seconds. We're starting to get a little bit more rapid fire. Is everybody following along?
Yeah.
Yes.
Seriously?
Yeah.
Yeah.
Yeah. 1 hour is 3,660.
Would we have our answer?
No.
We'd have kilometers per second. I don't want kilometers per second. I want meters per second. What do I need to do? Kilometers on the bottom and meters on top. Does that conversion exist?
Yes.
No. Is there
Kilometers
hectos in the
to
middle?
meters. No, there is not.
No, people.
Meter is the base.
And we don't care that hecto's in the middle. And hecto is in the middle, right? Is
Yeah,
that
it's
10 to the
two.
second?
It's
Yeah,
2.
that's fine. Okay, but I still have the conversion between meters and kilometers because,
You have the base unit.
1 meter.
yeah, there's a base unit, which we've been calling a core unit. What? Yes! Somebody said it.
Which part is it?
There's 1,000 meters.
Then I told you to memorize it. That's why you know that, because you were told that you have to memorize that conversion. Okay? Power of 10 goes with what?
3 meters.
The core unit. Which is the core unit? Meters or kilometers? Meters. 10 to the 3 goes there.
Over what?
Over 1. Okay? This means, for those of you concerned about this, the power of 10 is always getting placed with the core unit if you follow my method. If you follow that 100 centimeters is 1 meter thing, your power of 10 doesn't always go with the core unit. That's the problem with that method. It requires you to think more. If you feel your brain has not been stuffed with too much information and you can memorize more, go for it. I won't laugh, but I will be sad when you get it wrong. Okay? Now what happens? The kilometers will do a long distance cancel all the way across. Look at that giant distance. Completely irrelevant because
It's the next distance.
multiplication is communicative. It doesn't matter the sequence in which I do it. So it can be right next to it. It can be really far away from it, as long as all I'm doing is multiplication all the way through. Now what happens? I would take 105 times 10 to the 3. Give me a number. And then take 1 times 60 times 60 times 1.
3,600.
3,600. For those of you keeping track with numbers, 105, 10 to the 3rd.
You need to convert it down to 1 second, right?
Need to convert it down to 1 second.
You need to add another 0.
Is that all you were saying?
Yeah.
A second? Yeah. Because 60 times 60. Okay? Enter it in the calculator, you now have your answer in meters per second. Does that make sense?
Well, I know that's right, but I don't understand. Like, I thought there was like meters were supposed to be like opposite to number, like inverted. Oh wait, we don't need to cancel meters.
So, where I think you're potentially getting confused is if you were going to do a complex conversion to a complex conversion, micrograms to milligrams. Okay? And I think that's what you're thinking about is that particular example. In fact, it was milligrams to micrograms. Okay? That's why we had to stop through meters on the way through. Okay? Because meters allows us to do that conversion. Okay? Since you all seem super excited and rocking that, then we'll just kind of skip all of those. Volumes in 3 dimensions. This is really oddly placed because we actually just looked at the example that's challenging with it, the whole trap thing. Okay? Volume, length times width times height. Right? How do we measure volume? What's the unit? Liters. Does that have anything to do with length times width times height? Because length times width times height are measurements of distance. So why the sudden shift? Okay? It's not really a sudden shift. We just defined a new unit to represent that. Okay? I took a cube that measured 10 centimeters by 10 centimeters by 10 centimeters. Okay? That cube, if I multiply it all out, would get me 1,000 centimeters cubed. Why did I invent liters? How many of us like powers or exponentials? We don't. So what did we do? We invented a new unit that got rid of the power. Democracy, right? Or is it communism?
Yes.
Right? To get rid of the power?
Revolution.
There's power in every system. Sometimes you just can't see it.
Don't worry about it. So ultimately, that's what's happening. Okay, so volume can be measured by this kind of weird arbitrary unit of liters. We can also use it by measuring the weird arbitrary unit of distance. But if we use the distance value to measure our volume, we have to cube it. Okay, so it becomes a more complex solve because we have to do more calculations. It also becomes more complex because how often are our solids perfectly geometrically shaped? Very rarely. Okay, which means having a system of volume that is based off of just measurement or just distance measurements is not a good idea. We'd want a different unit system. That's why we invented liters as an alternative explanation. Okay? You could go through and do this conversion to come up with the conversion factors between centimeters cubed and milliliters. Anybody know what it is? Centimeters cubed and milliliters. It's 1. 1 centimeter cubed is 1 milliliter. You should be able to establish a conversion to see that that is true. You ever seen the movies, TV shows with doctors and stuff, like give me a cc? Cubic centimeter. It's the same thing as a milliliter, except saying give me a milli, I guess isn't as cool as give me a cc. Right? But it's that concept. That's where it's coming from. As you're measuring it in centimeters cubed, which is an interesting observation, right? Medicine, you'd think, America. What are we using to measure our system in? Metric. Huh. Okay. So, volume of irregularly shaped objects. If we were to measure that little star-looking shape, okay, we could probably pull out the mathematicians and they'd be like, well, we could approximate this as an oval, and then we've got all these triangles, and we could do half the base times the height, all that fun stuff, add it all up, and we would get the volume. Yeah, we could. We could also take a chemistry class instead of a math class. What if we move that out into 3 dimensions? So the mathematicians go, oh, we invented calculus for this. Thank you. So welcome. Okay? We could figure out through shapes and all calculations in the math for all that. What are we attempting to measure the volume of now, mathematicians?
A lot.
It's not the bowl. The gas coming out of said bowl. Okay? How do we measure the volume of a gas if I can't keep it in a container? Okay? I'd have to put it in a bag. Mathematicians are going to have a hard time with that calculation. Okay? So we want a way to be able to do that. How do we determine that volume easily? We do displacement. Okay? Did you say years of the life? What's wrong with it? Sorry, this is off topic. That's a pretty cool art exhibit for the record. Just my opinion. We could do volume by displacement. We can drop the solid object into our water. The water changes by volume. That volume change is due to the solid. So we can measure volume by displacement. Okay? We can do the same thing with gases. Gases become harder. We'll have to trap the gas in a closed system. That's what we've built out here. Okay, so if we look at this, what's happening is we're running a chemical reaction that produces a gas. That gas will fill the volume. So it's going to fill up this entire space. If it wants more space, what does it have to do? Push down on the water, which is going to cause the water to go up and collect out here. If we mark the graduated or mark this beaker on the far end with gradations, we can figure out the volume of the gas. This experiment does have an inherent flaw behind it, though. Have you ever taken a balloon and heated it up? What happens? It expands. The volume of gas is also temperature dependent. if this flame is too close to your measuring system, we're not going to be measuring the volume of the gas. We'll be measuring the volume of the gas and the expansion of it being heated. How do we minimize that? Get the candle as far away from where you measure it as possible. Okay? And minimize that distance. Okay? We'll talk about properties of gases, third unit. Okay? So we don't need to stress about that. I just wanted to point that out because I think it's an experimental flaw. Double replacement reactions. Ta-da! What's special about double replacements? It could have to do with gases. It's like single replacements, but twice as much fun. Okay? Double replacements, you're getting two things exchanging. In a single replacement, all that happened is we took one element by itself and we put it in a compound, which kicked out the other element to be by itself. In this case, those elements never are by themselves. They're just fully exchanged into different compounds. Okay? So we are expected to be able to predict what those products are. So if we take a look at that first equation, because we're awesome at nomenclature, we know that aqueous barium chloride is BaCl. AQ. Barium's a +2, chloride's a -1. That formula is incorrect. BaCl2. Are you responsible for knowing that? Yep. Reacts with potassium chromate. K. CrO4. How many of you know chromate is CrO4? How many of you know what its charge is? Ooh, that was questionable. How many of you need to know that by the exam on Thursday?
Probably all of them.
That was a trick question.
Everybody.
None of you. You are not responsible for knowing chromate. Watch the nomenclature video where I tell you which ones you're responsible for.
Oh, is it just the seven?
Yes. Chromate's a -2. Potassium is a +1. To balance that out, we need 2 potassiums. This was aqueous. I didn't hear you. I heard a C, a blah, blah, blah. Blah, blah, blah is not -2. Okay? Give that to me again. BaCrO4 plus KCl2. But it's going to be KCl, not KCl2. For whoever said the 2 there, why do you think you put the 2 there? Because it was on the other side. Why is the 2 next to the potassium and potassium chromate? To balance chromate. Is the chloride with chromate anymore? No, so you can't have the 2 there for that reason. Okay, we'll address that in a second. Is that formula balanced, KCl?
Yes.
Yes. Is the formula BaCrO4 balanced?
Yes.
Yes. Okay. Now we could go through and balance the equation. And in balancing the equation, is that all we need to add?
Yeah.
Yeah. All we need is that 2 next to potassium chloride. Okay. That is review. You should be able to come up with that fairly quickly. Okay. Remember when we talk about triaging? Balancing should be one of those things that's snappy so that you can spend a lot more time on conversions. Okay? So our equation is now balanced. You have predicted products, right? Extra layer of stuff to deal with on top of double replacements. Just like the single replacements, you had to predict if a reaction happened. How did we predict a single replacement if it happened? You had to use the activity series. Okay? That allowed us to see that we had a phase change. We don't have an activity series for double replacement. How do we predict that this equation has happened or not? We would need to know the phases of those materials. Potassium chloride says aqueous. Barium chromate says solid. How do we know those phases?
Because you're putting
Nope.
The one where we see them close to each other, like if one is above it.
That's referencing the activity series.
It's going to be included in the exam.
What will be included in the exam? This is not an activity series. This is double replacement, not single replacement. Solubility rules. Solubility rules will be provided for you. So you have to be able to interpret solubility rules to be able to get to this answer. Right? Yeah. Woohoo! Okay. Thought there was something else I was going to say there, but I don't remember what it is. So let's take a look at some solubility rules. Come on. Work with me. No, come back here. Solubility rules. So let's take a look at it. Notice these equations are not, well, at least that one, the top one, the barium comp one's not balanced. All we're asking is if it happens. If all I need to know is if it happens, do I care if it's balanced? No. Okay? So how would I decide? I need to determine if barium chromate should be a solid or potassium chloride should be a solid. Right? That's where these solubility rules come in handy. So I'm going to start with potassium. Okay? And what I'm going to do is look through these solubility rules until I see the symbol for potassium. That symbol is K. Why did I pick? It's not there, really.
No, it's an alkaline ion.
Killing me, Smalls. The very first line.
Come on, this is the only one.
K plus. It does not have to explicitly be written there, because what could be written there? Alkali metals. Are you responsible for knowing the alkali metals are the group 1 metals of which potassium is a member? Yeah. So it doesn't have to be written. But the rule says, Rule 1, alkali metals and ammonium ion. That's just a name. That's not a rule. What's the rule? It's the rule right above it, right? That first line. Compounds that contain those are soluble. How do you know it's soluble? What is the symbol for soluble? Well, soluble begins with S. So, of course, it's going to be AQ. Soluble in water means it dissolves in water, which means aqueous or aqueous, doesn't matter. That's why the potassium chloride is AQ. How about for the barium chromate? We do the exact same process. Fish through the list until you find barium. There it is. Cool. Where is it?
Number 9.
I see it right there in Rule 5. That's, yes, elaborate, that's barium sulfate. Which means? That was stupid, Mike. Don't highlight that because it's not relevant. You have to be able to reason through that. Don't just jump on it because you see it. Okay? Where does it show up? Rule 9. I'm looking at 10. There's 9. Barium and 10. Oh, interesting. It's not showing up. What the heck do we do? Well, it's not like a double replacement has 2 pieces, does it? Let's look for the other piece.
Number 7.
Now when we go to number 7,
See rule 1 exception.
chromate. What's the rule for chromate with where it's found in our list?
See rule 1.
That's exceptions. Generally, insoluble means it does not dissolve in water. Means solid. So we could say solid except there's exceptions. Those exceptions say, see rule 1. Is barium rule 1?
No.
No, which means not an exception, which means it's solid or it's a solid. Make sense? Okay. That's the process you need to kind of move through when looking at your double replacements. Exciting? It is not, nothing in this class is that bad. Come on. Give me a little bit of credit. You may not want to be tested on it. Right? But nothing in this class is that bad.